I'm thrilled to have you join me on this journey into the vast, mind-bending expanse we call space. Have you ever looked up at the night sky and felt a sense of profound wonder, a deep curiosity about what lies beyond our little blue marble? That feeling is the innate human desire to explore and understand, and it fuels our quest for knowledge. In this video, we're going to dive headfirst into that cosmic ocean. I've curated a list of 10 amazing, absolutely astonishing facts about space. They will challenge your perspective and ignite your imagination. We're talking about volcanoes that dwarf our tallest mountains, days that last longer than years, stars so dense they defy our everyday understanding of matter. These aren't just trivia. They are windows into the fundamental laws that govern everything, from the smallest atom to the largest galactic supercluster. If this kind of exploration excites you, do me a favor and hit that subscribe button. Let's start our journey close to home, cosmically speaking, on our neighbor Mars. When you think of a volcano, you might picture Mount Fuji. Impressive, yes, but they are mere foothills compared to the titan of the solar system, Olympus Mons. This isn't just a large volcano, it's a geological feature of such epic proportions. It stands nearly 22 kilometers high, or 13.6 miles high. That's almost 3 times the height of Mount Everest above sea level. The sheer footprint of Olympus Mons is staggering. Its base would cover the entire state of Arizona. If you were standing at the edge of its caldera, the vast, sunken crater at its peak, you wouldn't even be able to see the base of the volcano. So, why did Olympus Mons get so colossal? It's a combination of factors. Mars has a much thicker, more stable crust than Earth. On Earth, our tectonic plates are constantly moving, so a volcanic hotspot creates a chain of smaller volcanoes, like the Hawaiian Islands. On Mars, the crust stayed put over a hotspot. Lava piled up in the same spot for billions of years, building this single, monumental shield volcano. Olympus Mons is currently dormant, a sleeping giant. It last erupted millions of years ago. But its presence is a powerful reminder that planets in our solar system, while sharing a common origin, have evolved in vastly different ways. It challenges our Earth-centric view and forces us to consider the sheer variety of worlds that exist, just a stone's throw away. It's a geological wonder that makes our own planet's features seem almost quaint in comparison. Let's hop over to our other neighbor, the shrouded and enigmatic planet Venus. We often call it Earth's sister planet due to its similar size and mass, but that's where the family resemblance ends. Picture this. A single day on Venus is longer than its entire year. The planet completes a full orbit around the Sun faster than it completes one full rotation on its axis. Venus spins on its axis incredibly slowly, and in the opposite direction to most other planets, including Earth, a phenomenon known as retrograde rotation. A Venusian year is about 225 Earth days. A Venusian sidereal day takes about 243 Earth days. So, you could celebrate your birthday, your Venus Day, before the planet has even turned once. If you could stand on the surface of Venus, you would see the sun rise in the west and set in the east. Now, let's pull our perspective way, way back. Look down at your hand. Imagine you're on a beach, and you scoop up a handful of sand. Now imagine all the sand on that beach. Now imagine all the sand on all the beaches. Now imagine all the sand in every desert on Earth. Picture the whole planet covered, every grain counted. It's a number so large it's practically incomprehensible. And yet, the universe holds a far greater treasure. There are more stars in the cosmos than there are grains of sand on our entire world. Scientists estimate there are about 7.5 sextillion grains of sand on Earth. Our own Milky Way galaxy contains an estimated 100 to 400 billion stars. The Hubble Space Telescope's deep field aimed at a tiny, seemingly empty patch of sky. What it found was not emptiness, but a tapestry of light. Extrapolating from this, astronomers estimate perhaps 2 trillion galaxies in the observable universe. From the incredibly vast, let's now journey to the incredibly dense. We're going to talk about one of the most extreme objects in the universe, a neutron star. These are the cosmic leftovers, the collapsed cores of massive stars that have gone supernova. After the explosive death of a star between about 8 and 20 times the mass of our Sun, gravity wins the final battle. The core collapses in on itself with such unimaginable force that it overcomes the repulsion between atomic particles. In this cosmic crucible, protons and electrons squeeze together to form neutrons. The entire core, with a mass greater than our Sun, compressed into a sphere only about 20 kilometers or 12 miles in diameter. To put this density into perspective, a simple sugar cube. If you could scoop out a sugar cube-sized piece of a neutron star and bring it to Earth, that tiny cube of neutronium would weigh about 1 billion tons. Equivalent to the entire human population, or about 3 million Boeing 747s, all compressed into a space you could hold between thumb and forefinger. Of course, you couldn't actually do this. The moment that material left the neutron star's immense gravitational field, it would explode with unimaginable energy. But as a thought experiment, it beautifully illustrates the universe's extremity. Neutron stars represent a state of matter so alien they force us to rethink what's physically possible. We have a tendency to think of space as a perfect vacuum, a realm of absolute nothingness between the stars and planets. But like so many things in science, the reality is more nuanced and frankly more interesting. Space isn't completely empty. It's filled with a tenuous, almost imperceptible substance known as the interstellar medium. It's a very, very thin soup of gas dust and cosmic rays. How thin? On average, across the vast distances within our galaxy, the density of the interstellar medium is about 1 atom per cubic centimeter. Let's compare that to the air you're breathing right now. A cubic centimeter of air at sea level on Earth contains about 30 quintillion atoms. But the universe is vast, and even 1 atom per cubic centimeter adds up. This interstellar medium is the raw material from which new stars and planets are born. Over millions of years, gravity slowly coaxes these sparse atoms and dust particles together. So, the emptiness of space is not empty at all. It is a dynamic, active environment. It's the cosmic recycling plant of the galaxy. Let's return to our celestial backyard and visit our closest companion, the Moon. On July 20, 1969, Neil Armstrong took one small step, leaving the first human footprint on a world beyond our own. Boot prints. Tracks from the lunar rover discarded equipment from the Apollo missions are still there today, perfectly preserved. They will likely remain for an astonishingly long time, perhaps millions of years. Here on Earth, evidence of our presence is fleeting. Wind erodes surfaces, rain washes away tracks, tectonic activity constantly reshapes the land. The Moon, however, is a world in stasis. It has no atmosphere to speak of, no wind, no rain, no weather. The only force that significantly alters the lunar surface is the constant slow rain of micrometeorites from space. But until then, they remain as silent monuments. Let's venture out to the king of the planets, the gas giant Jupiter. This colossal world is a tempestuous place, covered in swirling clouds, violent storms. One of these storms stands out above all others, a feature so large and persistent it has been observed for centuries: the Great Red Spot. The Great Red Spot is wider than our entire planet. At its peak, it was up to 3 times Earth's diameter. It's an anticyclone, a high-pressure system with edge winds screaming at more than 400 kilometers per h, about 250 miles per hour, far faster than any Earth hurricane. What's remarkable is its longevity. Confirmed observations go back to the 1830s. It's a self-sustaining vortex in a sea of gas, powered by internal heat and rapid rotation. Observations in recent decades show the storm is shrinking. Scientists are watching to see if it will disappear, or if this is a temporary phase. The Great Red Spot is a natural laboratory for fluid dynamics, a magnificent, violent spectacle that reminds us of the power and scale in our solar system. We've talked about the scale of the universe in terms of the number of stars, but what about its size? We often hear the figure that the observable universe is 93 billion light-years in diameter. But this number can be confusing. If the universe is only 13.8 billion years old, how can we see things that are farther away than 13.8 billion light-years? It's a fantastic question that gets to the heart of cosmology. The key word here is observable. The observable universe is a sphere with us at the center, encompassing everything whose light has had time to reach us since the Big Bang. But here's the crucial part. While that light was traveling, the universe itself was expanding. The fabric of space-time is not static, it's stretching. So that galaxy that was 13 billion light-years away when its light reached us, is today much, much farther away. The expansion of space has carried it to a current distance of about 46.5 billion light-years. Since we are at the center of our own observable sphere, the edge is 46.5 billion light-years away in every direction, giving us a total diameter of 93 billion light-years. This also means there is a vast universe beyond what we can see, a cosmic horizon, beyond which light has not had time to reach us. It's possible the universe is infinite. Let's head back to our solar system for a fun, and honestly a slightly absurd thought experiment starring the beautiful ringed planet Saturn. Saturn is the second largest planet in our solar system, a gas giant over 9 times the width of Earth. But despite its massive size, it has a surprisingly low density. In fact, it is the only planet in our solar system that is on average less dense than water. Saturn's average density is only about 0.69 grams per cubic centimeter. This is because it's composed primarily of the lightest elements, hydrogen and helium, so this leads to one of the most famous and delightful facts in astronomy. If you could find a bathtub large enough, Saturn would float. Now of course, this is purely a flight of fancy. As soon as you placed it in the water, the immense gas giant would dissipate and mix. We began our journey with incredible scale and we will end it with incredible density, returning once more to the bizarre world of the neutron star. Let's upgrade from a sugar cube to a simple teaspoon. Imagine taking a teaspoon, the kind you stir your coffee with, and scooping up a sample of a neutron star's core. That single spoonful, barely a few cubic centimeters, would have a mass of approximately 6 billion tons, more than the weight of all 8 billion humans on Earth combined. The weight of 900 Great Pyramids of Giza, 900 pyramids piled up into something that would fit in the palm of your hand. This is the power of gravity run rampant. The result is a material so dense it pushes physics to the absolute limit. And there you have it. 10 glimpses into the staggering, awe-inspiring, and sometimes downright weird reality of our universe. From the colossal mountains of Mars to the impossible density of a dead star, the cosmos is a place of endless wonder. I hope these facts have sparked your curiosity as much as they continue to spark mine. Thank you so much for joining me on this cosmic adventure. Now I want to hear from you. Which of these facts blew your mind the most? Let me know in the comments below. Finally, if you enjoyed this journey, please show your support by hitting that like button. And make sure you're subscribed so you don't miss our next voyage into the unknown. There's a whole universe out there waiting for us, so as I always say, keep your eyes on the stars and your mind open to wonder. Until next time, keep looking up.